All right, we are live. Cool.
We are at 5 and we will start our model soon.
Yeah, the next would be training the model, but before that, let's just
Should we start training our model by right away? Because it might take a while, right?
let me check. Yes. Oh no, it won't take that much.
Okay.
Hmm. So basically, what we learned in this step was that there are three main things to look out for: optimizer, scaler, and scheduler.
Mm-hmm.
And what they basically do is optimizer gets the trainable parameters of the model, and Mhm. सोचो तुम घने कोहरे फॉग में एक पहाड़ी पर खड़े हो और नीचे उतरना है। तुमने पूरी वैली नहीं देखी, सिर्फ अपने पैरों के नीचे का ढलान स्लोप पता चलता है। ऑप्टिमाइजर वही बंदा है जो ढलान देखकर अगला कदम लेता है।
Listen to the optimizer, bro. That is the person that is going to take those cautious steps.
Precautious steps. But what if the slope is slippery?
Oh my god, then they will have, that altitude that is going to step.
Why is our stream? Yeah. No. So setting LR 0.02, कदम कितना बड़ा है, बड़ा इज इक्वल टू तेज लेकिन मिनिमम को क्रॉस कर सकते हो, छोटा सेफ लेकिन धीमा. Okay, so LR is basically the length or speed of the step.
Mm-hmm. Not great.
Yeah, one of the hyperparameters that we tuned while working with the text completion model. Momentum 0.9, पिछले डायरेक्शन का 90% याद रखो, जैसी गेंद लुढ़कती है. पिछली डायरेक्शन का 90% याद रखो. मोमेंटम इज पिछली डायरेक्शन का 90% याद रखो. ओ नहीं अटकती और एक ही डायरेक्शन में रफ्तार पकड़ती है. वेट डी के 5e-4. वेट डी के इज डूइंग हर स्टेप पर वेट्स को हल्का सा जीरो की तरफ खींचो. इससे कोई एक वेट बहुत बड़ा नहीं हो पाता और फिटिंग कम होती है. Hmm. ओवरफिटिंग कम होती है इटरेशंस का हिसाब. Iters per epoch. Hmm. Also, while I'm eating, let me just pull up the question for lead code today in our agenda. Technical interview prep. Many robotics companies don't prefer straight up lead code questions. They give you practical coding knowledge check questions like this. Okay, do you have any idea about this kind of stuff?
What?
Look at this.
Write a Python script that passes inference server logs to calculate P95 latency by model version P25 R window. This is known as P95 on a sorted list. Is sorted valve. Use statistic drop down by key. Default it and no to talk about streaming as loading of all loading it all if the file is fixed. No, bro, nothing. I think it's more about inferencing, but I don't know how this P95 latency and all those things works.
Robotics company tests this type of questions to check the candidate's practical Python knowledge under mild pressure.
Dude, they are not checking for person's Python knowledge at this point. They're checking person's infrastructure and inference knowledge. Like this is more for an AI engineer level question that they might ask. But this won't be only for like checking your Python or knowledge or like that thing.
Practical coding experience, so I think.
Yeah, like the bar is something else. It's not like they are checking.
Yeah, but like question, like this is like a straightforward question that somebody reported on Glassdoor
Mhm.
that was asked to them
Yeah, so
in a
yes, like
robotics.
they are definitely looking for more than lead code. That's what I'm saying.
Yeah, brother. So we need to practice this as well. I don't even know what the fuck is a P95.
I also don't know, bro.
Okay, know that a P95 on a sorted list is sorted vals int 0.95. Hmm. Yeah, so we can dive a little bit into this today, and
Mm.
I'll anyway get the question as well for lead code. Do you want something easy today?
Anything works, bro. Anything works.
Mm, Ah, this is interesting. Lead code 146. You will start reading it right away, aren't you?
No, dude, I won't. I'm trying to spin up something else. So yeah, let's focus. What happened with the training thing?
Yeah, one second. I was just eating. That's why I was just spending some time in putting our agenda in order. Lead code LRU cache. Have you solved this one? LRU cache.
Yeah, I think I have. Please recently used. This was the one, dude. Like we have done this in our database.
Hmm.
We have not done a code, but we have this concept in our database.
So this is what we're gonna do today, and that question. All right, synthetic data. We need to finish this today, anyhow. Mhm. ओके, हर स्टेप पर वेट को हल्का सा जीरो की तरफ खींचो, इससे कोई एक वेट बहुत बड़ा नहीं होता, और फिटिंग कम होती है. ओके, so weight decay is basically something that controls the overfitting of the model.
Mm-hmm.
It prevents the overfitting. And then iters per epoch, total iters, num epochs, iters per epoch, warm up iters is equal to min 500 total liters divided by 10 num epochs, iters per epoch, total liters. Okay. एक इटरेशन इज इक्वल टू एक बैच पर एक अपडेट, एक epoch, पूरा ट्रेन डेटा एक बार देख लिया. लेमन मांगा एक इटरेशन एक बैच पर एक अपडेट एक epoch इज इक्वल टू. ओके. Hmm. 77 train images, batch 16, 5 batches, 5 iterations per epoch, 20 epochs into is 100 iterations. एक iteration, एक batch पर एक update. Where are the number of batches defined over here?
Mm,
एक बैच पर एक iterations, max one line train loader, total iterations, number of epochs into iterations per epoch. एक बैच पर एक अपडेट. So iterations per epoch is 5, and number of epochs is 20, and iterations per epoch is 5, so 100 total iterations. And warm-up iterations are min 500 or total iterations divided by, so 10. Okay. एक इटरेशन एक बैच पर एक अपडेट एक epoch पूरा ट्रेन डेटा एक बार देख लिया. हमारे पास 77 ट्रेनिंग इमेजेस हैं, बैच 16, 5 batches, 5 iterations per epoch, 20 epochs.
What the fuck you watching?
I'm not watching anything. My phone started ringing.
Oh my god, who's calling?
Body calls.
Oh my god,
Late night body calls.
late night booty calls.
No, bro, it was just an alarm.
Shit, bro. Late night booty calls.
Who will call, brother?
You never know. You never know.
But I know.
You never know. It's fine. But
So 77 is divided by 5, which is batch 16. So 5 batches. 5 into 16 is what? 70? No. Oh, almost 80. So 20 epochs, 100 total iterations पूरी ट्रेनिंग में मॉडल सिर्फ 100 बार अपडेट होगा. फॉर्मूला मिन 10%, लेकिन 500 से ज़्यादा नहीं. यहाँ 110 more iterations. ओके. असली सी 100 इटरेशन बहुत कम है. असली डिटेक्शन ट्रेनिंग 10,000 प्लस इटरेशन होती है. ये बस स्टेप 7 का लो एमएपी समझने में काम आएगी. इसे सीखने का मौका मिला नहीं. 6 to 12 are. Okay, so this function linear warm up then cosine decay as a multiplier on base LR. Line 6 to 12. If it is smaller than warm up iterations, return it plus 1 max of 1 divided by max of 1 plus 1 and warm up iterations. Hmm. Do you understand this if loop? What it is doing?
1, 2, go, 1, go. Max LR underscore at. What is LR underscore at?
Learning rate. And where is that?
LR, so the function that we have, LR underscore at, that is the function that.
Yeah, this is the function, bro. Like, this is the function that is going to do it.
So, no, so what is LR at doing? Is it the linear rate function or it's like,
Linear warm up, then cosine decay as a multiplier on the base LR.
hmm.
सबसे पहले एक चीज साफ करो, ये फंक्शन लर्निंग रेट रिटर्न नहीं करता, ये एक मल्टीप्लायर रिटर्न करता है हमेशा 0 और 1 के बीच। असली एलआर बनता है एक्चुअल एलआर इज इक्वल टू लर्निंग रेट इनटू एलआर एट इट इज इक्वल टू 0.02 इनटू 0 से 1 के बीच कोई नंबर। एंड वेयर इज दैट रिटर्न? दो हिस्से, हिस्सा 1 रिटर्न it plus 1 divided by warm up iteration, it equals to 0 1 by 10.1 to 5 6 by 10। धीरे धीरे 0.02 से 0.002 से 0.02 तक चढ़ता है कोसाइन डीके। ओके, प्रोग्रेस इज इक्वल टू इट माइनस वार्म अप इटर्स डिवाइड बाय टोटल इटर्स माइनस वार्म अप इटर्स। कि कितना परसेंट हो गया वाला नंबर है कोसाइन का जादू। np dot cos np dot pi into np dot progress। oh, cos multiplier, cos 0 is 1, cos 90 is 0, cos 180 is pi was 180, right?
3.14.
Bro, in terms of angles, like pi by 2 is 90
Pi by
and
2 is 90.
so pi is 180.
Hmm. Its cos pi by 2 is 0. That's 90. Oh, yes.
180 degree.
Cos 180 was 1.
Yes, pi by 2. Yes, pi radians is equal to 180 degrees. Pi by 2 is 90. Pi by 3. Damn. High school maths. But how is it resulting exactly in 0 से 1? कोई झटका नहीं, कोई सीधी लाइन नहीं। Okay, scheduler is equal to toss dot optim dot lr scheduler dot lambda optimizer my way। Okay, second, I'll be back। Hmm. So it's saying over here scheduler is equals to torch dot optim dot lr scheduler dot lambda lr optimizer lr at. Torch dot optim lr scheduler lambda lr optimizer lr at. Torch dot amp grad scaler CUDA enabled use AMP and device type is equal to CUDA. Hmm. Step 2 table. FP16 का component exponent सिर्फ 5 बिट्स का है, मतलब उसकी रेंज छोटी है, बहुत छोटे नंबर FP16 में सीधा 0 बन जाते हैं। अंडरफ्लो और ग्रेडियंट्स अक्सर बहुत छोटे होते हैं, जैसे 0.00001। 100 total. Hmm. Hmm. Okay, so it's asking to plot it ourselves over here. Total iterations not defined. What? Oh, I guess I have to run all the cells.
Hmm.
Structured numpy, converter defined, raw data. Hmm. Ground truth with augmentation. Nice. Graph is plotted. Hmm. This is our YouTube view graph, bro.
Like
Shoot up
automation.
and then
So this is our learning rate. So it shoots up and then it starts to decay around or okay.
because warm up is
So our warm up is set by us. Is it because of that?
या
Oh,
एक कर्व जो तेजी से ऊपर चढ़ता है 10 इटरेशंस तक फिर धीरे धीरे नीचे आता है और एंड में लगभग 0 पर पहुंच जाता है। वार्म अप शुरुआत में संभल के चढ़ाई वार्म अप शुरुआत में संभल के पीक बीच में सबसे बड़े कदम जब मॉडल तेजी से सीख सकता है ढलान कोसाइन एंड में छोटे कदम ताकि मिनिमम के आसपास सेटल हो जाए। स्टेप 3 में हमने देखा कि बैकबोन प्री ट्रेंड है लेकिन आरपीएन और आरओआई हेड स्क्रैच से बने हैं, उन्हें कुछ नहीं पता इटरेशन 0 पर क्या होता है। अनट्रेंड हेड बिल्कुल रैंडम प्रेडिक्शंस, बहुत बड़ा लॉस, बहुत बड़ा ग्रेडियंस। अब अगर एलआर फुल 0.202 पर है, ये बड़े ग्रेडियंट्स बड़े स्टेप वेट्स में बहुत बड़ा झटका और झटका बैकबोन तक भी पहुंचता है, वही बैकबोन जिसे इमेजनेट पर मेहनत से ट्रेन किया गया था। तुमने जो प्री ट्रेन नॉलेज लोड की थी वो पहले ही कुछ इटरेशन में खराब हो जाती है। लॉस स्पाइक करता है कभी कभी नैन भी। वार्म का फिक्स पहले 10 इटरेशंस में एलआर छोटा रखो। हेड को थोड़ा सा सेटल होने दो, जब तक फुल एलआर आता है ग्रेडियंट्स तब तक रीजनेबल हो चुके होते हैं। एक लाइन में वार्म अप अनट्रेंड हेड को प्री ट्रेंड बैकबोन तोड़ने से रोकता है। कोसाइन डी के एंड में क्यों? सोचो एक तुमने कटोरा बोल में गेंद डाल रहे हो और वो बिल्कुल नीचे सेंटर पर रुकनी चाहिए। बड़े कदम गेंद सेंटर के आसपास आगे पीछे उछलती रहेगी, कभी रुकेगी नहीं। कदम धीरे धीरे छोटे, गेंद सेटल हो जाएगी। कोसाइन वही करता है और कोसाइन ही क्यों? सीधी लाइन क्यों नहीं? क्योंकि कोसाइन बीच में ज्यादा दर तक हाई एलआर रखता है और डी के एंड में तेज करता है, यानी मॉडल को सीखने का ज़्यादा वक्त मिलता है और सेटल होने का भी। एलआर और बैच साइज का रिश्ता स्टेप 1 कनेक्शन डॉट ई एन में लिखा था। एलआर इज इक्वल टू 0.02 एट बैच 16 स्केल लिनियरली, बैच साइज 0.01 0.02 एंड 0.0। क्यों? बड़ा बैच ज़्यादा इमेजेस से एवरेज ग्रेडियंट इज इक्वल टू कम नॉइज ज़्यादा भरोसेमंद डायरेक्शन। बड़ा कदम ले सकते हो, छोटा बैच शोरर वाला ग्रेडियंट। शोरर वाला ग्रेडियंट।
Shorter, I guess. Can AI make mistakes?
छोटा कदम लो वरना भटक जाओगे। अगर तुम बैच साइज बदलो और एलआर ना बदलो तो स्केड्यूल का पूरा शेप गलत हो जाता है। हम्म। AMP was what? Average mean precision, right?
Yeah.
AMP is true. एंड तुमने एलआर को प्लॉट करके देखा, चढ़ाई फिर ढलान, तुमने पता है। और नहीं तुम्हें पता है वार्म अप क्यों एग्जिस्ट करता है, अनट्रेन्ड हेड बड़े ग्रेडियंट्स, तुम्हें पता है। हमें अपना टोटल एड्रेस नंबर याद है यहाँ 100। I'm still a little unclear on this part. This one.
बड़ा बैच ज़्यादा इमेजेस से एवरेज ग्रेडियंट तो कम ज़्यादा प्रोजेक्शन प्रोडक्शन बड़े तो कम ले सकते हो छोटे बैच शॉर्टर It's, I think it's shorter wala gradient, not shorter. I think it's shorter.
Yeah, but what does that mean?
Equal to छोटे कदम लो वरना भटक जाओगे. Okay, so बड़ा batch ज़्यादा images से average gradient equal to कम noisy. Okay. So it's saying that, dude, if we have more data, then we can do a lot more iterations, and we can have broader. We can take large leaps in our descent, like descent or action when we're trying to calculate our gradient descent or gradient
Mhm.
ascent using our learning rate. So, for example, I would say that, let's say you have 2000 images, right? And in those
Mhm.
2000 images, we are trying to identify a specific object, and that object can be a brick or any construction cone, right? So if we have more
Mhm.
number of iterations of those objects, our model will be able to differentiate between a noisy or a wrong cone or maybe an inverted cone as compared to a cone that is perfect, since it will have more number of training neurons and training data, and we can take larger leaps for the same things. For example, let's say you're trying to look at the data and you have a vast amount of data, right? And when you have a
Mhm.
vast amount of data, what you can do is, while training it, you can increase your learning rate, since the data that you are putting inside the machine learning model is really large, right? So you will have a larger amount margin of error, because the data that you are pulling in, like the data that you're trying to insert or train the model on,
Mhm.
a lot of number of samples. So even though if your model skips to learn couple of things, it's gonna learn eventually, since you will be training it
Mhm.
on a larger amount of data. But as compared to a
Mhm.
smaller batch that it talks about, so that means that you will have a smaller gradient. Why it will be smaller gradient? Because you will have a less margin of error. Because what you're trying to teach model is that, hey, you have 10 images, and based on this 10
Mhm.
images, we have to maximize our learning. What is the maximum thing that you can learn, right? It's like, okay, the more
Mhm.
our model practices, right,
Mhm.
the more it will get better, and it will have more it can make more margin, it will have a larger margin of error, because at that point the learning rate is so broad that even though if it skips something to learn, it's going to eventually learn in the other training runs. But as compared to the model that is trained on a shorter batch, it will be really difficult for that model to ingest everything all at once, right? So that's why we will train our model slowly and by using a smaller learning rate, that, hey, learn this much, and then we will see what happens. Learn this much, then we will see what happens. So what we're trying to do at this point is, with a smaller amount of data, we want to get the maximum neurons and maximum learning that we can get. while we're computing our matrices and everything. So that's what it means over there, I guess. That if you have
Mhm.
a lot of images, then you will have less noisy and more trust, more source fidelity, like fidelity data. Like whatever you are doing in a correct direction, since you have a large amount of data to train. But if you have a small
Mhm.
batch, then you won't be able to have those kind that kind of freedom, since your model can like won't be able to differentiate between something that it hasn't trained on at all, right? The more the
Mhm.
sample, and that's why we have the synthetic data generation. Synthetic data generation solves a problem like I would say in the same manner. If you have more data, like synthetic data, then our model will learn and simulate much more better as compared to a lesser amount of or a smaller batch. If it
Mhm.
if it is trained on for the same, even though the time it took for training is going to be the same, but since it has not been exposed to a larger amount of samples or questions or probabilities, the output it will generate on testing will obviously be like I would say not better than the model that is trained on a larger amount of training data set and testing phase.
Mhm. Okay.
Mhm.
Hmm. I get it. Hmm. Got it. All right. I think we can move to the training.
Okay.
अब जीपीयू गरम होगा. The first epoch prints a measured throughput figure and an estimate for the full run. Checkpoints go to the results, and the best model by validation (MAP) is kept separately. Detection models overfit synthetic data readily, so the last epoch is often not the best one. Okay. इस पूरे स्टेप का असली कोड सिर्फ 6 लाइन का है, बाकी सब लॉगिंग, टाइमिंग और चेक पॉइंटिंग है। ये 6 लाइन हर पायटॉर्च ट्रेनिंग लूप में होती है। एक बार समझ गए तो ज़िंदगी भर काम आएगी। ओह! What are these 6 lines? Optimizer dot zero grad set to none is equal to true. Scalar dot scale loss dot backward. Scalar dot unscale optimizer. Torch dot nn dot utils dot clip grad norm model dot parameters 10. Scalar dot step optimizer. Scalar dot update. Scheduler dot step. पुराने ग्रेडियंट साफ करो, फॉरवर्ड लॉस निकालो, बैकवर्ड ग्रेडियंट्स निकालो, क्लिप ग्रेडियंट्स को लिमिट में रखो, वेट्स अपडेट करो, एलआर बदलो। pretty straightforward. ट्रेनिंग लूप की शिक्षा। ओके ओके, एएमपी के 3 हिस्से और उनका ऑर्डर उल्टा करने पर ट्रेनिंग चुपचाप गलत हो जाती है। चुपचाप।
Chup chap.
ऑप्टिमाइजेशन और जीरो ग्रेड क्यों बार बार चाहिए और ना करो तो क्या होता है? I just remembered that we were at our friend's place and we were going back home at 2 in the like 2 at night,
Mhm.
and then there were some shots
Oh my god.
fired.
Oh, and then we ran. Ran into the den.
Faster than the bullets.
I think I was taking directly in the
Bro, I think there was nothing.
no, no, bro. We were just tripping.
But there was one guy with us that was not tripping, but he ran his.
Dude, I think he was tripping also. I don't know, bro.
Bro, oh my god, bro. Those were the days. God damn. Ran like bitches. Alright, optimizer dot zero grad क्यों हर बार चाहिए और ना करो तो क्या होता है? Gradient clipping is finite guard do safety nets. Hmm. हर इपॉक हर बैच डेटा जीपीयू पर भेजो, लॉस निकालो, ग्रेडियंट्स निकालो, वेट्स अपडेट करो, इपॉक खत्म करो, चेक पॉइंट सेव करो। Hmm. Okay. Mm. So loss, forward loss is what exactly? Can you remind me?
What?
Forward loss is what exactly?
So
I think I remember it, but can you remind me?
yeah, I'm trying to recall as well. Wait, I don't want to be incorrect. That's why I'm not speaking of. Forward loss or forward pass? Loss drift model image, comma targets. Oh yeah, okay. Got it. So basically, forward loss is when we are comparing our outputs against our targets that
Ye-
we are trying to generate.
So it runs as internal forward pass and computes the loss in one call, returning a dictionary of individual loss terms instead of prediction, something like that. Okay. Oh, this is what we saw earlier.
But we saw it for backward, not for forward. Okay, have you started the training?
I run the block now.
Okay.
Okay, let me run this block.
No, it's running, I guess.
Now it's running. I started it.
Wait. I think it ran already. That's why you are on to the next block.
No, I just did shift and enter.
Go up. But if you would have been on the same block, it should, yeah, it ran already. This is not.
Bro, I just did it. This just
Yeah,
changed the
but we are
block.
not training yet, dude. We have just initiated that function. We are not training yet. The training will start in the other block
Oh,
for epoch. See, training complete, last checkpoint, and now the training will start. Yeah, see the star over here. You see, there's a star
Where is the star?
like next to the history in the block, in the cell block. There's a star.
Oh yes, that means it's running.
Yeah, that means it's running. So once it gets executed, it gets a number. That is going to be like 22 or 23 over here.
Hmm. Kernel status busy. Executed 0 of 1 cells. Elapsed time. Error. What?
Oh, try again. Your
Uh,
kernel died. Fuck.
huh?
Rerun, restart your kernel. Go to kernel and restart and clear output, and then you have to come back and run until over here.
Bro, I think there's something wrong with the
Do
tailscale.
reload. Oh,
Yeah,
dude,
my connection got cut.
the server died. Wait, let me see. What did the fuck? Was running anything as such? What is the what port are you on? For what port are we at in the Jupyter lab? Uh,
8889. What happened?
yeah, bro. I have to repoint. I think something messed up on my side. I'm trying to repoint it.
Oh, it started.
Started right? Okay, perfect. Yeah.
Okay, it has started now.
Nice. Let's see how long it does it take. What is it saying? How long will it take? I guess it's not. It should not take that long. Maybe like.
5 minutes.
Do you think it's gonna take 5 minutes? We should have some kind of loading bar. Oh, there we go. Oh, it's done. Oh, it's gonna take 7 minutes. It says that. Oh, we are doing epoch one, epoch two.
Mm,
Oh, our loss is okay. So we can see our loss. If we take a look at our loss, the initial loss was 0.96. And by the second epoch, we learned a lot. By the third epoch, okay, it increased and it's now decreasing. So we are like closing at around 0.22, 0.20.
So it should not take 7 minutes. I think it will be done in 2 minutes.
Uh, do you know how the first LLM was trained?
How?
It was a fluke. Like the researcher went on a holiday and he left his model training for a while. It was so initially LLMs were not learning at all, but
Mm,
then when given enough time, they were able to learn. Like the training loss were initially like zero. We
mm,
were losing it a lot, but then they left it for like I think months, 1 or 2 months, and then after training for a while, the model started to learn. That's
mm,
how the LLM got alive. Like you have to train them enough.
mm.
That's why like memory outages.
$96 billion 1 quarter.
So what was the lead code question that you're talking about? Let me take a look at it once.
LRU cache.
Oh, LRU cache. Oh, it's gonna be simple. Yeah, I do remember it.
Simple.
Yeah, it's not that difficult. If we know LRU, then we can do it. It's basically testing our object-oriented design structure and all those things. LRU,
Mm,
like it's required, but it's not the LRU cache.
mm.
Design a data structure that follows constraints of LRU cache. So for this, I think we have to use stack and queue, I guess. Wait, what is hash table linked list? Okay, W linked list. Okay, we have to use linked list as it says over here. But you can see. Hmm. Initialize LRU cache with positive size int get int key. Return the value of the key if the key exists. Return -1. Void put int key int value. Update the value of the key if the key exists. Otherwise, add. So put one. If we do LRU cache is gonna be initialized with capacity 2. Okay. So dot capacity equal to capacity. That is one thing we would initialize. And so dot okay okay. Key object dot get key. LRU cache, and then we are gonna do put. So dot dictionary equal to default dict, something like this. Cache is 1 equal to 1. Put 2 comma 2 cache is 1 equal to 2 equal to 2. Dot 1 3. The LRU key was 2. Evict key. Okay. Booty call.
Everyone, no, bro. Mom's calling. On
I'm just messing around.
Hmm. Okay, I think the training should be complete.
Mm.
Yep. Training complete. Okay, so this is the loss curve.
Yeah. Okay, is it the training done? Is that, I think not.
Yeah, training is complete.
Oh, nice.
And this is the graph of loss, training loss. EMP1 with torch.amp. Oh, this one.
Mm-hmm.
Okay, so forward pass को half precision में चलाओ autocast. This is what this is doing, I am guessing.
ब्रो कोई वही 6 स्टेप्स बस एम की 3 लाइन बीच में घुसी हुई है पूरी बार यही है।
Hmm. Hmm. A washing machine. Bro, you have a fucking headphone, right? Which has a microphone.
No, dude, I don't do not have such kind of things.
What the fuck? You had that thing. I remember, like, what was that headphone?
Bro,
Sony
it broke
MX5.
like that thing broke. I have to get it fixed.
Wow. Hmm. Bro, I miss my Apple AirPods Max.
You can still get them. Why are you missing them? Go to a refurbished store and get them. Get them.
Bro, I don't want to spend that much money again. That was like fucking.
Get Apple Gear this time.
Fuck it. I still have them, bro. Like, they just don't work. I still have them.
Wow. So
I don't know what
why do
code
you
I
have
use.
them if they don't work? Like okay, what you can do?
What should I do? Like, I should I
You
just.
can okay if you're planning to go to India, you can get them fixed over there. Like maybe it might like to a local shop or something.
I don't think in India they would be able to fix it.
Dude, they are able to fix it, dude. In India, why do you think they won't be able to fix them in India? Dude, India is a place of jugaad, dude. Like if you give it to your dad, right? He's gonna get it fixed for sure. He will send some chotu and like get this thing fixed somehow.
Oh, but they still are good for noise cancellation.
So what's not working in them on them?
The headphones are not working. Like, I cannot connect or turn them on or anything.
Oh, okay, 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 okay.
And it's probably because I used them in the gym and the sweat got inside the thing.
Hmm. So yeah, it might be like an IC fix or something. Like if you, I would say that that's what my plan is for with my Sony as well. I'm gonna
Mm,
take those to India and get them fixed over there. It's gonna cost like 20 or 50 bucks max.
mm, mm,
50 would like way too much. Like 20 bucks are only for the parts that I might take it from over here and
mhm.
get them fixed over there.
I'm thinking of doing it myself over here with a kit because I don't think in India people would be able to fix.
Dude, people are able to fix your underestimating people a lot in India, dude. Like I have gotten a lot of things fixed in India. Like they do
Mm,
have a broader. It's all about like electronics and every other stuff, right? For them, I have my
mm,
iPhone, dude. I went to a local shop and I asked that guy, hey, like so I went to I would say Apple store and I asked them, hey, what is the solution for this? And that guy is like, hey, it's gonna cost. You have to replace your motherboard.
mm.
That's what he said to me.
Hmm.
And then I asked him, "Hey, how much?" And then I went to another store that was like a local shop, and I asked him,
Hmm.
"How much for this?" And he told me 800 rupees. That's it. The Apple store was telling me to replace the fucking motherboard, and that guy like, "Hey, there's a IC burn, so I might be
Hmm.
able to fix your phone." It was iPhone 7, and they do
Hmm.
have some problem like that, that the IC will go off, and then you won't be able to listen or hear, make any calls or something like that.
Hmm.
And that guy charged me like only, I would say, max 1,000. That's it for the IC to replace the IC. So, and that was like a,
Bro, if somebody is able to fix my these AirPods Max for $1,000, I would be fucking
not
out
for
of.
1,000 bucks, not for 1,000 bucks, but I think three on top it would go for three grand, including the inflation. But at that point, it was like 4 years back when I had iPhone 7, or 5 years back.
Mm.
So I'm gonna,
Bro, 3,000, bro. I'll give four.
okay.
I'll give fucking 4,000.
Yeah,
But if
take them to India. Like definitely, dude. Someone would be definitely able to fix that shit. But that's what I'm gonna do. Like I'm gonna take it to India and get it fixed via like some cheap ass shop. Because I would have
mm,
all the parts. I just want someone's delicacy that he's able to open that part and repack it properly.
AirPod Max.
Like if you look up on YouTube or somewhere else, you will definitely find some videos or something.
Oh, damn. People are fucking doing this shit.
Dude, I'm telling you, like in India, if someone is getting headphones of fucking 50 grand, right? Oh, they won't be like, it's not like in America we have insurance, right? In India, they do not have any insurance shit. You just go to a local vendor shop and it's gonna be cheaper as compared to over here.
Buzz me.
Uh,
Sorry, it's 3.5K.
that's it.
Yeah, that's what it is.
I told you. Told you. And the only damage, I guess, is with the IC. That's it. Like your IC might be fused or burned, and then they might replace that IC. That's it.
Hmm.
And if this has happened to you, this might happen to a lot of people.
Claude Code.
Yeah, bro. This is like, I think this is not cloud code. This is, I guess, codex or lovable. Dude, yeah,
They forgot to fucking add the image.
yeah, bro. Too much vibe coding.
Too much. Yeah. Where's the price? But whatever, fuck it. I'll do that. No one would be happier than me if they start working again for just 4 grand.
Yeah, bro. They will. I also thought that like I would have to get my iPhone motherboard replaced and all that shit. But bro,
Hmm.
yeah, the fix is real cheap. They will ask you to replace the motherboard because they do not want you to like come back and have the same issue. But
Hmm.
that's like a temporary fix. It would go bad. It would go bad again if the same
Hmm.
conditions have like are being induced in the environment. That is the problem with that.
I see. Whatever. Alright, so the training is complete. ओके सो लेमैन ग्रेडियंट जीरो से बाहर जाने के सीधे नन को कर दो मेमोरी बचती है और थोड़ी तेज भी क्या होता है बैड और ग्रेडियंट जो होता है रिप्लेस नहीं करता अगर तुम क्लियर ना करो तो इटरेशन टू का ग्रेडियंट इटरेशन वन प्लस इटरेशन टू में
Oh,
Okay, so why is clearing the gradient so important? Oh, एन अगर एक बार मॉडल में घुस गया तो पूरा मॉडल मर जाता है और आगे नंबर एन हो जाता है, रिकवरी इम्पॉसिबल, एक बार स्किप करना सस्ता है, पूरी ट्रेनिंग दोबारा चलाना महंगा। हाँ, so this is a very important step actually. Zero grad set to none is equal to true.
it basically resets the.
Here's the gradient. Yeah.
Yeah.
Alright, well, let's do the lead code now. I need to sleep early.
Okay.
We should finish this tomorrow because there's only two steps left now.
Okay. Okay.
2, 7, and 8, which is just evaluation and result.
Mhm.
This is just evaluating and this is just some export optional shit. So I think tomorrow we will be able to finish this completely.
Hmm.
And the original thing that we started this for, we can get back to that.
Yes.
This one. Oh. Hmm. Now the fun part is going to start, brother.
Mm-hmm.
Yeah, I think that was a good decision. We created two projects, policy training and synthetic data generation with for fine tuning.
Mm-hmm.
And then now the next project that we are going to start is going to one is going to be this. We are going to complete this guide, and then the other one is the one that I am working so that we can set up our instructs.
Nice.
So I think we should be in a good shape before October,
Yes.
so that we can just go and join a startup easily.
Brother. That's what they're looking for. Bring in an arm and we give you an oven.
You never know, bro.
Uh-huh.
Life is full of unexpected gifts and surprises. We just need to show up. Oh, by the way, register for this.
Is it open?
Oh, but I think it's only in person, so I don't know if you'll be able to. There's a hackathon.
In New York?
Yeah,
Mm.
but they require approval, and I think it's in person.
Mhm.
All right, I'll start the timer for allow you cash.
Yeah.
Or do you want to directly jump to the solution? But do we need to
Like I have
solve this?
started, like I have started it. So if you want to directly jump to the
Bro,
solution,
what the fuck?
I almost wrote 20 lines earlier as well.
Bro, why? Why the fuck do you not wait?
Okay, so when we were training, right? So I completed the question at that point only, like, because I knew.
What did you know? Bro, what the fuck is wrong with you?
I was just testing out, okay, if my logic and what I'm thinking.
Bro, you can do that when I start the timer then as well. Why the fuck? What's the point in the timer if you are just gonna do it beforehand?
You know, I couldn't stop myself, but from next time I'm gonna stop it.
Bro. Okay, I'm gonna start the 25-minute timer.
Okay.
Okay, design a data structure that follows the constraints of a least recently used cache. Discard least recently used item first. This algorithm requires keeping track of what was used when and when is cumbersome. It requires age bits for cache lines and tracks the least recently used cache lines based on these age bits. When a cache line is used, the age of the other cache lines changes. LRU is a family of caching algorithms that include 2Q by Theodore Johnson. Um, A0, B1, A0, B1, C2. Mhm. Mm. What the fuck?
What up, bro?
Yeah, bro, I don't get it at all, so I'm just looking for the solution now.
Okay, so yeah, let me walk you through it.
Why is your camera off?
But yeah, I'm trying to turn on the camera. I don't know, for some reason it's not coming back. Oh, I think it was. Yeah, there we go. Yeah, I don't know what kind
Let
of.
me understand the question first.
So okay, open that Excel you draw.
Wait. Yeah.
Okay. So yeah,
Hmm.
yeah, create.
I know what the LRU algorithm is,
Okay.
but so they are saying just design a data structure that follows the constraint
Yeah.
of this. And by data structure, they mean like a object-oriented class.
Yes.
And implement LRU cache class, LRU cache int capacity initialize LRU cache with positive size capacity.
Mm-hmm.
Uh, I sort of get this initialize LRU cache with positive size capacity, like some sort of capacity need to be passed in form of an integer to keep the cache. For example, we if oh shit, if this is our what do you say, the data structure,
Mm-hmm.
right? 6, and our cache value is 5,
Mm-hmm.
or let's say 7,
Mm-hmm.
5, 6, 1, 2, 3, 4, 5. Okay, let's say 6.
Mm-hmm.
So this is going to be our data structure with a cache value of 6,
Mm-hmm.
right? And then it's saying int get, int key, return the value of the key if the key exists, otherwise return -1.
Mm-hmm.
I don't know what that is, what key it's talking about. Void put int key into value, update the value of the key if the key exists, otherwise the add the key value pair to the cache. If the number of keys exceed the capacity from the operation, evict the least recently used key. The functions get and put must each run in O1 average time.
Mm-hmm.
Complexity, okay. And then it explains the input, right? I have no idea how that output is coming.
Okay. So
One.
so if we so what this is what how we so what we are trying to design over here is a library or a
Mm-hmm.
class, right?
Mm-hmm.
So what we are trying to do is when we call this class. So if you take a look at the go at the code, and if you scroll down on the code side,
Yeah.
how we are instantiating our class, right? LRU cache capacity. That means
Mm-hmm.
capacity is a variable that you are passing in, right?
Mm-hmm.
So if you take a look at the input says LRU cache. So what it means over here is over here, like in the example one,
Mm-hmm.
right? The input in the first array it says LRU cache. That
Yeah.
means first we will initialize our LRU cache class.
Mm-hmm.
And then
Mm-hmm.
in that, what we are gonna pass, we are gonna pass two. That means the capacity of
Oh.
LRU cache will be two,
Mm.
right? So this is how this is what we are trying to build, right? That this is
Mm.
what their goal is, that hey, you have to create a cache that act like this. Now
Mm-hmm.
you have to use multiple data structures. Like there are a lot of ways that you can solve it, right? So I solved using dictionaries. I'm going to show you that, but the proper way, if we go with that, is going to be linked list and W linked list, right? But
1, 1. Okay, so it's saying cache is LRU cache 2. So 2 would be the capacity, right?
yeah,
So the data structure would look something like this, right?
yeah,
And now it's saying put 1, 1.
yeah,
So 1, 1 would be over here in the first one, right?
yeah,
And then it's saying put 2, 2, right?
yeah,
So 2, 2 comes here.
yeah.
Now it's saying get 1. So it needs to take it out, right?
No, so that's the thing that you have to design.
Oh, get is this. Okay, what does it get?
That is the thing that you have to design.
Return the value of the key. Okay, so 0 and 1.
Yeah.
This is 0 and 1, right?
Yeah. No. So
So
the
it's
key.
saying
No. 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 So the key is 1, 1. So that means one is the key for 1, 1. For 2,
what?
2, two is the key. Like the array that you have, right? 1, 1 and 2, 2.
But they, so you're
Have
saying
to
this
take
is
a
1 and this is 2.
look at the look. No. No. Look at the code. Look at the code again. How is
Mm-hmm.
that taking key and value? Look at line number 16.
Key value, type value, what?
So the code is saying that this is so one is going to be the key and one is going to be the value that in that array when we are passing two values
What
over.
the fuck does that mean? One is going to be the key and one is going to be value. What is key and what is value? What are you saying?
So look at what put look at what does put method requires and how are we passing it. You have
Put
to.
requires self, key, and value,
Yes.
right?
Yes.
So, okay, so when we pass the put over here on this value,
Yeah. So
then we had to get some key as well.
yes. No. So no, you have already passing key in that.
Oh, so this is the key and this is the value.
Yes. Yes.
Oh, yeah, now I get it. So, bro, when I said 1 comma 1 over here, you should have corrected me.
But I was like, okay, I was gonna explain you later on. That's why I was like, okay, let's carry on. Okay.
Now I
Just
get
trying
it.
to get like, what are you trying to say over here? Like, maybe I was like, okay, you might get it later on, but yeah. But then you started saying wrong, so I have to correct it.
So,
One.
this is 1
Yeah.
and this is 2, but the key of this is 1
Yes.
and the key of this is 2.
Yes.
And now it's saying get. Get is just the key.
Yes.
So, get of 1,
Yes.
right? So, get key 1. So, what is get gonna do? It's gonna remove the
Yeah.
value of key 1,
Yeah.
right? So, this is going to be popped out.
Yes.
Okay, so we can remove this,
Yes.
but this stays as 1.
Yes. This will be popped out and popped back again
When
at the same time.
popped out and popped back again?
Yes.
Why?
So that your queue moves ahead. You are gonna pop out, but then you're gonna move it. So LRU, least recently used. So since
Yeah.
one is used, so two will be the least recently used, right? Since we just called one that, hey, are you there? That means
Mm-hmm.
this this key becomes.
Also, it's not getting removed; it's just getting accessed.
Yeah, so it's getting access, but it will be rotated back. Like the priority in the array will change, so one will come back before two.
Oh, so this is basically if we access this, this is gonna take this place and this is
Yes.
gonna take this place
Yes. Why? Say why?
because of the LRU algorithm.
Yes, yes, yes. Like in our logic, we have to do that.
Mm-hmm.
Otherwise, the logic won't work.
Mm-hmm.
Right? Now, to do that, we have two options. Either we can use dictionaries. That is going to be the simpler approach, like the most basic approach.
Mm-hmm.
Or you can use linked list. So I have started using dictionary, but we can also like look at the solution for.
Wait, but let me complete the whole thing.
Okay.
And over here it's saying void put. Okay. Int key, int value, update value of the key if the key exists. Otherwise, add the key value pair to the cache. If the number of keys exceeds the capacity from this operation, evict the least recently used key. Okay. So let's go through this first and then we'll solve the then we'll add the whole code.
Okay. Go through it.
So okay, so you got okay, so it's saying get and then it put 1, right?
Yeah.
Now it's saying put 3 comma 3.
Yeah.
So put key as 3 and value as 3.
Yes.
But and since 2 is the least recently used,
Yes.
so we'll remove 2 and add 3,
Yes, but we will add it in the back. No, no, yeah, we will remove. Yeah, yeah, you're correct. You're correct. You're correct. Yeah, yeah, you're correct.
right? And the key is 3.
Yes.
The key was here 1. So now we put this and then now we want to get 2. But 2 does not exist.
Yeah, the two does not exist. So what will happen?
-1.
Yes. That's
So returning -1 will do what?
nothing. Returning
Nothing.
minus one will return minus one. You can say
Oh, like, oh, okay, okay. Null, null, 1, null.
so. Any put operation will return null or error.
Okay.
That means if it
And any get operation will return 1
any
if
value
valid
or
and
minus one.
if -1 if invalid. Oh, Got it, got it. Now put what? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Put 4 comma 4,
Uh,
right?
that's why it is null over there. So just
Mm-hmm.
another operation. Now then you will
So
do
now what will be the least recently used? 3 again, right?
just three again. Now yeah. No, no, no. Wait. Did we use one? Did we recall one?
No.
No, no. One comma one will be wait. One comma one will be the least recently used now. So
So
you
bro, you should have told me that we have to move this over here now.
no, but you said it correctly, right? But that's why I was like, okay, you are already doing that using arrows. So
Arre
now you had to
bro.
already replace it with four, bro. Just replace it with four.
Yeah, now 3, oh sorry, 1 will be replaced by 4
Yeah.
because it was the least recently used. So clarify me one thing.
Uh-huh.
Oh, we can just use this over here. Okay.
Uh-huh.
If one, like if one is over here, let's say, right? And 3, we added 3 by removing 2
Mm-hmm.
over here. So now what will become the least recently used one, right?
Wait, why are you adding? It's 4 comma 4. You are adding three. Wait, like
Bro, what the fuck is wrong with you?
is this a hypothetical situation?
Why do you fucking zone out and zone in after like
Look, come again, come again, come again, come again.
come again? That's what she said.
Oh, yes, sir. Come on. Yes, sir.
So what I'm saying is let's go back to when this was 2 and this is 1,
Yeah.
right?
Yes.
Because we accessed 1.
Mm-hmm.
So
Yeah.
what I'm saying is now 2 becomes the least recently used.
Yes.
Then we visit this and this says put 3 comma 3, right? So we will remove 2
Mm-hmm.
and then add 3,
Yes.
right?
Yes.
Now
Now key is
will
also three. Add key as three as well.
yeah, bro.
Correct.
Key is 3 and the key for 1 is 1, right?
Mm-hmm.
Now what will become the least recently used one?
Yes.
So
Because
this will
you
get moved,
access
right?
that updated what?
So this will get moved to the front.
Yeah, basically it will get moved to the front.
So this is 1 and now
Yes.
this is 3, right?
Yes.
And now when we say get to, this will just return -1, so we don't need to worry about it. But 4 comma 4 is put,
Yes.
right?
Now replace one.
So we'll replace 1,
Yes.
right? Because that was the least recently used.
Yes.
Yeah, that's what I was trying to understand.
Okay.
And now it's saying get the key of 1, which is going to be -1 again
Yes.
because 1 is not existing anymore. Now it says get 3,
Mm-hmm.
so it's going to access 3
Mm-hmm.
and it's going to return 3.
Now it has become most recently used.
Yeah, so it's
Total.
again going to go here.
So this is the operation that we have to do every time. So whenever we are accessing
Hmm.
any element, then we have to pop it and push it back.
Hmm. And then it says get 4, and so it will just get 4. Now I get it. So that's the whole algorithm.
Yes.
Now the working of these 3 functions in this class. Let's see what ChatGPT says. Hash map plus double linked list.
Yes. So that is the perfect, appropriate and perfect solution.
Why the fuck is it saying it in English? I didn't say it say anything in English.
Yeah,
What?
it has got subconsciousness. Dude, we have been plagued.
What? But I was doing it in Claude. How did this start doing it in English?
We are fucked. We are fucked. I guess last days before
I am so ready for the AI takeover, bro.
AI takes over.
I'm ready for it
Takes over the AI.
because AI is going to
You
know.
should try this nothing headphones, I guess.
Yeah, bro, they are 150. I did
No,
think
no,
of
it's
getting them.
109. It's 109 on Amazon. Yeah, look it up.
But yours, I don't know what version are you
But I'm
on.
looking at headphone A 2026, new adaptive active cancellation. Just go to Amazon.com, bro. Yeah,
Which
go
one
to
are
this.
you seeing?
Yeah, this one. This wait. Let me share this.
Why is one 223 and another one 119? What is the difference?
I think it's the color, I guess. Okay,
No, what the
just add.
fuck? Color. 100 bucks for a color.
Sometimes it could be sometimes the color, bro.
It's not an iPhone, bro.
Hmm. Dude, you never know. Yeah, I think the 109 one are cheaper variant.
Why am I not getting $109 one?
I don't know, bro, because I saw it on Slick Deals. That's why. I have sent you the link.
Yeah. Ah, this one. Yeah, bro, I don't need it right now, so
No, but I was just saying you that if you can give this a try, if you want,
I don't want to spend money on this, bro,
like
right now.
even if they get wet, then at that point as well, you know.
Oh, I think these are a little different than the ones over
Yeah, these are
here.
the cheaper ones. That's what I'm saying.
Hmm.
Cheaper.
But what is 5 HD mics ultra bass is 135R,
I don't know, man.
and what is
Yeah,
this?
fuck it, bro. Fuck it. Let's go back to.
Bro,
Oh,
you distract me a lot. Yeah.
mm. Okay, yeah.
Bro, damn.
Yeah, bro.
What?
Nothing. Nothing. Nothing.
Why is it making two classes?
Nice. Oh, holy shit, bro. My solution is like pretty fast because I use dictionaries. Yeah.
Calculate the complexity first for
Complexity.
your solution.
Dude, I guess my complexity is gonna be off one only because I use dictionaries. That's what I'm saying.
I think we should build a complexity calculator for
Dude, the
programs.
complexity calculator already exists on the lead code submission chart. You can ask it over here at any point. If you want
Bro,
to.
but that is paid.
No, bro, that's fucking free. Once your submission gets accepted, then you can check.
Yeah, but what if I want to check before that?
Then calculate it, motherfucker, and ask Cloud Code. What is the fucking.
Okay, so what is it doing? Class node.
Yeah.
So it is adding two classes. One is class node and one is class LRU
Okay,
cache.
bro, do you know what is linked list?
I remember it.
Do you know what is double linked list? That is the.
Bro, I have done it, but I don't remember it
Okay, okay.
perfectly.
So if you don't know, then you have to first understand that. Otherwise, it's going to be like you see the self left dot next right dot prev. You're gonna get fucking confused at these 2 points, and you're gonna bang your head. So yeah,
Wait.
look at your notes or nodes.
Sliding window. I think I have done linked list. Let me.
Okay, if you have done English, if you recall it, can you just draw it so that
One
we can
second.
make sure that we are on the right page?
Two pointer to some hash table, hash maps.
Oh,
No, bro, I have not done linked list at all.
okay, bro. So, okay, do you want to learn it right now?
I will do it on my time, bro. I will do this.
Then, dude, this solution is that only. Like you have to
I
understand
know.
those linked list and that part, and then you can go through the solution. Otherwise, it won't. It will be really difficult for you to understand it.
Hmm. Oh wait, let me see. Sliding window. I did sliding window. Binary search. Take a big problem and cut it in half over. Okay, so binary search, and then I did BFS, flood fill, binary. Yeah, bro. I have not done linked list.
You have to like understand linked list either in your time or whenever you also plot chat GPT.
Backtracking.
Bro, how come haven't you even linked list? Like that is one of the most basic.
Let me see if I can recall if I've done linked list, but I don't see them in my notes, so I probably didn't do it.
Okay, bro. So yeah.
Way to store a sequence of items where each item points to the next one. Pointer. Think of it like a chain. Oh, I have done linked list, bro.
Nice.
Wait.
Okay, just if you recall it, then yeah, we can work through the solution.
1 second. Yes, I have done linked list. Yes, sir. Do you see this?
Oh wow. Yeah. There we go.
A list where you're just using pointers to link things together in computer's memory. So if there's a pointer called OX123. It's gonna point to a cell which is OX123, and then that is gonna have a pointer called OX16 that is going to point to another pointer. This is an efficient use of memory. No longer need to have things contiguous back to back in memory. Print nodes in a linked list with a while loop. Create a data type node, type def struct node into value struct node star next colon node, y struct node comes next. Now, for the same type of structure we're currently defining, star next declares the pointer next that points to another node in the list. Next stores the address of the next node. Address of the next node, okay. Now, prepending node to a list means adding a new node at the beginning of the linked list. So, node star list is equal to none, null. So, linked list is just like a data type, right?
Yes, data structure.
Data structure, sorry.
Structure, yes, brother. So yeah, now you have understood that. So yeah, we can go to the solution. That's what I wanted to like make sure
Yeah.
that you know what linked list is. Okay, now yeah, we can take a look at our code. So what we have is we are initializing key, value, previous state, and next state, right?
Mm-hmm.
Like, these are the two pointers that are really critical over here, right?
Previous and next, these are the pointers, right?
Yeah, these are the pointers that will help us to get the direction of next
Mm-hmm.
node, like what exists on the next node, right?
Mm-hmm.
Now, if we like take a look at our LRU cache, right? We are initializing capacity, as we know,
Mm-hmm.
and initializing a cache dictionary, right? And we are initializing two nodes.
Mm-hmm.
These are going to be
Self dot left, self dot right.
these are
LRU side and
going
value
to be
side.
our
Okay.
directional nodes that will help us direct. Okay, where are we going to point?
So least recently used and most recently used.
Yes.
Mm-hmm.
Now we are gonna use our next to point self dot right, and we are gonna use our
Mm-hmm.
dot previous to point to self dot left. So whenever
Mm-hmm.
these are being called, these will be equal to like right. That's what we are trying to make sure.
Mm-hmm.
Whatever our right has, so they are also gonna be the nodes.
Mm-hmm.
Right now we need to create some function. So one of the function we have to create is the remove.
Remove. Mm-hmm.
So do you understand how we
Get.
are removing the node?
Wait 1 second. What do you say?
Do you understand how we are playing with the nodes?
Yeah, yeah, yeah. We created two pointers and then we basically
You have to make sure to go through that, because this is a tricky point. Like removing a node and then repointing it to the correct one is like you have to use the swaps a lot. So
mm-hmm.
this, like, I won't say you can memorize the pattern, I would say, because this is a swapping pattern that you have to do. Like if you take
Mm-hmm.
line 23, you have previous node, then that is pointing to the no previous node, like node dot prep. And then
Mm-hmm.
your next node, right? You now have two nodes in your temp position and their location and their address that they're pointing to, right? Now what
Mm-hmm.
we're doing is we are using our previous node dot next. Now we are looking at the next node from that previous node, right?
Mm-hmm.
Where is it? And we are skipping the node like node pointer to next node,
Mm-hmm.
right? If you take a look at line 26, like if you want to visualize it, that would be really easy for you. If you are not able to get, like, do you understand how are we doing that? How
Wait.
are we playing with the nodes?
Remove a self node. Okay, node was key zero value. Okay. Key value dot pref. Okay. And over here, node self dot left is gonna be put in node. Okay. Self dot next dot next is equal to self dot right. Mm-hmm. Okay. And now previous node is equal to node dot prev.
Dude, node is the argument.
I know.
So if you're looking for node, node is gonna be passed via the other function. So node can be anything. Self dot left or self dot right can also be a node, right? So you have to basically understand whatever node we are picking, we are playing with that.
Mm-hmm. Okay. What were you trying to visualize over here?
So like you can create three boxes,
Mm-hmm.
three boxes separately, and point them like a train to train like yeah train 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 bro. Yeah.
Yeah.
All right. Okay. Right. So right now this is our current situation that we have in. Right. So
Mm.
what this remove method does is it's gonna remove this block. So we are right now pointing. So our node dot next
Mm-hmm.
previous node. So like for node one, like okay, let's name the nodes A B C. Yeah, let's name the nodes A B C.
Mm-hmm.
So for A, the node dot next will be B, right?
Yeah.
Okay, and for C, the node dot so for B, the node dot next will be C.
So node dot A is equal to B. No, node dot next.
Node dot next.
But how do we do node dot next over here?
We are using node dot next over here, right? Node dot next
So
is
A dot next.
yes, A dot next.
Okay. Mm-hmm. Hmm. Yeah.
Right, and then we will do B dot next equal to C.
Yeah. Yeah, I get it.
You get it, right?
Yeah.
Instead of doing A dot next to B, we will do A dot next to C. And this is how we will remove this node,
Mm-hmm.
right? This is how we will remove this node, and that's how our removal will work. But since
Mm-hmm.
this is a doubly linked list, right? So B will also point back to A and
Mm-hmm.
also point back to B.
Yeah.
So what we have to do at that point is we have to do C dot prim. Like over here,
Mm-hmm.
dot prim equal to prim underscore node. Like over here, we are doing next node dot prim. So whatever the next node, its previous will be the previous node that is gonna be the A.
Mm-hmm.
Dot prim will be A. Instead of B, right now it's B. But to select
Yeah, call
node,
it A dot next.
yeah,
Yeah. Mm-hmm.
yeah. Now you get it. So that's what you are
Yeah.
trying to do in the remove method,
Yeah. Got it.
right? And now for insert, it's pretty simple that we will know.
Right before self dot right mean most recently used position prep dot node is equal to self dot right dot prev.
Get it?
Previous node
So whatever
is equal to
right
self
node we
dot.
have is of the previous will be that previous node. So from our current node,
So
that
okay, but just one doubt. I haven't done object-oriented programming recently. So this node is going to be the self, right? Over here. So node dot right dot
node,
previous.
no dude, it's not
What
gonna
is it gonna be?
gonna be this. So if you have self over here, that
Mm-hmm.
means you can call this variable from anywhere. If you go up, you have the self dot right dot prim.
Mm-hmm.
You're calling basically self dot left node.
Yeah.
right? And to call that, you can use the self, and you can call the value whatever exists at that point. Self dot
So
right.
self dot left will come over here,
Yes.
and self dot left would be what?
It would be a MRU side node, like self
Oh
dot.
yes.
Yeah, right.
Okay. And
Now whatever node you have, you're gonna take a look at the next of it,
mm-hmm.
and then you will take a look. Then you will choose that as a node, right? And then once you have that, then you're gonna look at the previous node of it, and then you're gonna point it to previous prev underscore node, right? You
Mm-hmm.
visualize this as well if you want to, but this is kind of kind of complex to like just go through the code.
Wait, I'll ask it to visualize it.
Oh yeah, that would be great. Yeah, bro, this English shit is like crazy to visualize, but once you get it, that's easy.
I have already gotten what the logic is. I just need to understand the code now. Oh shit.
What happened?
Alright, bro. I think I can do it tomorrow, or like I'll do it on my own time because I
Yeah,
need to
like this
sleep.
is this part like I can explain you by visualizing it directly, but whatever works for you. But this is something that you have to understand for linked list. Otherwise, you won't be able to understand the code like that. That if you are just looking at the code and trying to understand what it is doing, it's going to be really difficult.
Mm-hmm.
But
Yeah.
if you
Okay.
are able to visualize what it is trying to do, like in the code, then yeah, you will get it.
Mm. Master Shazam, Abhishek Chaudhary back in chat.
Multiple members are recalling.